So what were the expectations of the European Commission regarding the work program? So the project that will be presented today, PHOENICE, AeroSolfd, and VERA, they come from two different calls. So the first one, PHOENICE, was a call from 2020 and was focused on hybrid light-duty vehicles. So the goal was to develop advanced energy generators specifically for hybrids and to optimize the driveline for a thermal system, and also to assess the real-world environmental impact and emissions. Then we have, in 2021, another call where we had two projects that have been selected, AeroSolfd and VERA, and the goal of the call for this topic was to address older vehicle emissions with low-cost retrofit technologies. So we have we were very focused there on the low cost of the technologies that were developed. The goal was to tackle the nanoparticles, but also other emissions like ammonia and also the brake emissions. It was not only for vehicles, for road vehicles, but also for rail. So I will now introduce the speaker of PHOENICE. So it's Mr. Tony Tattoo that will present you this project. He works for the IFPEN, so IFP Énergie Nouvelle. And so welcome, Tony.
Hello, everyone. Thank you, Salima. So I'm Tony Tartour from AFP Énergie Nouvelle, and I'm pleased to present today PHOENICE project, which is a PHEv toward zero emissions and ultimate internal combustion engine efficiency. I'm going to structure this presentation into 5 parts. I will present the project partners, then the objective of this project, then I will introduce the baseline vehicle, since we are developing a prototype vehicle, and finally, development and results with the conclusions, actual activity, because this project ends this month, so there's no further activities. We are 8 partners from 4 different countries: IFP Énergie Nouvelle, Centro Ricerche Fiat, FEV Europe, Johnson Matthey, Marelli, Europe, Politecnico di Torino, Garrett Motion, In Extenso Innovation. Additionally, we have a third party, which is FEV Italy. The estimated project budget is around 6 million euro. This project started in January 2021 and will end this month. The objective of PHOENICE project is to demonstrate the maximal potential of a plug-in hybrid vehicle optimized and redesigned to reduce both fuel consumption and pollutant emissions under real driving conditions. In terms of pollutant emissions, you can see the PHOENICE target in the first column that is more stringent than Europe 7 as compared in this table, specifically for particulate number, and NOx. Additionally, we have some unregulated emissions that you can see here, formaldehyde, N2O, and NH3. This is regarding the emission target. In terms of efficiency, we are aiming to achieve 47% of efficiency on the thermal engine. That brings us to around 5 to 10% of fuel consumption, considering charge-sustaining mode, because we are dealing with a plug-in hybrid vehicle. Let me now introduce the baseline vehicle, which is a Jeep Compass from Chrysler, so Stellantis Group. This vehicle is a PHEv, SUV PHEv. We have an internal combustion engine, state-of-the-art, with 1.3 gasoline direct injection, wastegate turbo, and also, we have a variable valve actuation system, which is multi-air. Additionally, 2 electrical motors that are positioned in P0 and P4, and reference autonomy of 50 kilometers. However, it will be simulated to 80 kilometers during this project. This is the baseline vehicle. How to achieve our project? So we are working on different groups. You can see the first group is the dual dilution combustion engine. Dual dilution means lean combustion, so dilution by air, but also exhaust gas recirculation. That will allow us to achieve, with additional technologies that we are going to see, to achieve 47% of efficiency. In parallel, we developed new components for the dedicated exhaust after-treatment system for lean burn, and in order to meet our target. We can list an electrically heated catalyst, a new GPF with a specific coating, and also SCR for NOx abatement and lean conditions. We also investigated the potential of global efficiency, increasing efficiency using an exhaust heat recovery systems. We investigated 2. And finally, once we have developed the different components and we redesigned some components, we needed vehicle integration and development of additional control. So the integration of this new internal combustion engine, the exhaust after-treated system, and the other parts were done according to emission-based energy management strategy. Let's start with the development of the prototype engine. We started as a baseline with the 1.3 GSE called Fiat engine, which is a serial engine on this Jeep Compass. We increased the compression ratio because you know that theoretically the maximum efficiency of internal combustion engine is directly linked to the compression ratio. We also adapted the con-rod. Additionally, we developed a cooled low pressure EGR system with Velaers that was implemented on this engine. We have modified the cylinder head by applying the AFP Swamble approach in order to boost the flow motion. The fuel system was increased to 350 bar of maximum pressure instead of 200, which is for the serial engine. We performed an additional optimization of the VVA system, and our partner, which is Garrett, developed specifically for this vehicle an electrified turbo. So an E-turbo with a VNT, variable nozzle turbine, replacing the Westgate serial turbo. It is a 48-volt E-turbo boosting system. So all this modification and all these new components were implemented, and we manufactured 4 prototype PHENICE engines. First one for steady-state calibration, so experiments. Second one for transition calibration at Polytechnic Torino. First one was based at AFP Energie Nouvelle. Third one for the vehicle integration, and a fourth one is a spare part. In parallel, we also developed a digital twin. So starting from Stellantis, Centro Ricerche Fiat gave us a reference model for the reference engine, and Polytechnic Torino upgraded in order to have PHENICE prototype model. It was validated with the first really very early engine results, as you can see. And this digital twin was used in order to pre-calibrate. You can see here an example on the right side of pre-calibration regarding the variable valve actuation. And once we have identified the best set through this PHENICE digital twin, we consider them as a starting point to further experimental optimization. We installed the first prototype engine at AFPN engine test bench, and we performed different optimizations. So I'm not going through all the parameters because we have a big number of parameters. But this first graph illustrates the final results in terms of indicated efficiency On the y-axis, you can see the brake mean effective pressure. It's an image of torque. And on the x-axis, we have the engine speed. And you can see that we were able to achieve almost 47% of gross indicated efficiency. What does that mean? Compared to the reference engine, we are between 5 and 15% of efficiency improvement. So this right side figure, the same y and x axis, illustrates the difference in terms of percentage between the prototype engine and the baseline engine. This can lead us around 10% of global efficiency. Regarding the after-treatment system, the exhaust have two parts. So the closed couple one, which is typically for lambda 1, so gasoline lambda 1 after treatment, we start with an electrically heated catalyst for reducing emission during engine cold start. We have a new three-way catalysis, a new GPF with a specific coating. So this is a closed couple for lambda 1. But also we have implemented and developed new components for the NO oxidation in order to optimize the NO and NO2 ratio, because it's very important for the SCR reaction. Then we have the urea system, the SCR, selective catalyst reduction, and also ammonia step catalyst. All these components were specifically developed for PHENICE in order to achieve the target of pollutant emissions, but also tested before the assembly that was done by Marelli. And this assembled exhaust line equipped the second engine, which is for transition calibration, and the one that go to the prototype vehicle. We have performed also transition calibration. I'm not illustrating because of the lack of time, but at Polytechnic Torino, in order to calibrate the engine to switch between different modes, low, lean, lambda 1, EGR, depending on the coolant temperature and on the exhaust temperature. So this is to perform a kind of trade-off between the exhaust emissions, but also the engine efficiency. Once this is done, you can see the right side, we deassembled the normal production vehicle. Then we have implemented all the different components, but also we have a new 48-volt system because the e-turbo and the e-cata needed this 48-volt system. However, successful integration was done by PHev Italy with the support of Stellantis. And also, functionality testing of the installed SCR urea dosing was performed. I will go quickly because we will see more interesting picture and video later. The last phase was to fine-tune this vehicle calibration in order to comply with the worst real driving emissions. So this is worst because it's relatively, we developed it at work package 1. During this project, you can see very impressive acceleration. So here we cannot see the slope, but it's almost 2 hours of RDE cycle with different velocity. It can be to 100, it can go to 135, almost 140 kilometers per hour. So the calibration is proven. The vehicle is developed for final tests that are going on this month because it's the last month of the project. And the last task is to validate this prototype on WLTC cycle to assess the CO2 gain with respect to the reference vehicle, but also to status regarding the emission, pollutant emissions. In terms of, yes, this project provides new high efficiency combustion system, also the study of the potential of heat recovery system, the exhaust after treatment system developed specifically for a lean gasoline engine, but also a lot of know-how and methods for virtual calibration methods. Those are the communications that we were presented. And I can summarize here, but to not repeat what I mentioned, I prefer to go through some images and video. So if you can, yes, please. Okay, good. So those are from this month, so are very recent. That's why they weren't integrated in the presentation. So this is a prototype vehicle that is prepared to go through the test. And here you can see all the prototyping in terms of control. You can see all the area systems that was installed. So this is only let's say, partial view of the system. Here we can see the F-tier specifically here in order to measure the unregulated emissions in addition to the particle number emission, for example, and also the classical emissions that were measured. This is all the components that were very well integrated, so we can close the hood and we can drive the vehicle. So this was a challenge because we have EGR, we have many components. And here is a video, for example, during the RDE calibration cycle that we can see. Here you can find the same cycle as I illustrated on my slide, and you will see the driver trying to follow this cycle. Here's the cycle, and here's the driver is trying to silence this deceleration, and then you have acceleration. On x-axis, you have the speed. So this is PHENICE project that is running on the defined RDE cycle. Thank you for your attention, and I'm happy to take any question later.
Okay, so we will have a Q&A session at the end. So I would like to welcome now for the project AeroSolfd, Mr. Martin Lehmann, which is the Principal Expert Research Network and Public Funding at Mann & Hummel in Germany.
Thank you, Salima, for welcoming me to the RTR conference. It's always great to be here. It's a conference where we are used to acronyms. It started with CACI, and now we are with AeroSolfd. Usually when I'm presenting, people ask me, that's a typo, isn't it? But it's not. It's a great project, and I'm going to talk to you about that and let you know why. It's a fast track to cleaner, healthier aerosols by market-ready solutions of retrofit filtration devices for tailpipe brake systems and closed environment. So I don't know why VERA is now coming up. That is not my slide. That's the next project, a sister project. We are going to collaborate. So this is the AeroSolfd, and we were addressing the call that was given in, as Salima mentioned, 2021, to come up with affordable solutions for reducing emissions of tailpipe, railway, and so on. So what we promised to work on the reduction of emissions for the tailpipe by having a particle filter introduced with our partner VERA. For the brake emissions, we were doing a passive brake dust particle filter developed by Mann & Hummel and applied to a ZF brake. And for the metro stations, to retrofit them in an affordable way, you can't change the HVAC system, but you can place filters over there, as we did in the pandemic time, and we will do that over there with a partner to demonstrate. So what you need partners to do the measurements. So we put together a team, VERA as an association in Switzerland, having long experience with exhaust emissions. We also had Link and Utah, a research institute, well known for brake emissions measurements, and we have CONCAWE as a partner providing access to buses and metro stations, and we have also IDIADA, a well-known institute running tests on metro stations, Teresa Moreno. Once you have the data, the next step is to assess them, to relate them to an impact. And that is what we are doing with the partner CINEA, with the partners NFA in Denmark. We look at an environmental, social life cycle assessment, not only a life cycle assessment, but also looking at the health effects, because that will be the key to later sell and implement the solutions. The other thing, you only have a strong impact if you have a good demonstration. So we were lucky to get partners to demonstrate the vehicles across Europe and also in Israel on a higher temperature level. We were also happy to have partners, bus companies in Ljubljana, in Ancona, in Spain, Avasa, together with the city of Valladolid, a very innovative city, to help us with the demonstration. And of course, for the Metro Lisbon, if you follow them on LinkedIn, you see what all the great innovations they are doing. So we have great partners to do that. And to get everything together to give us as a team, we are happy that Steinbeiß is supporting us. So that's what we promised and what we are going to do. So how far are we and what have we done and what we have achieved? The key is to have a good environmental social life cycle assessment. We have a framework. We don't have the data yet. You can see that we are still missing. To do that environment assessment, we are waiting for the data, and I will explain later a little bit, but that will be the key for the introduction. Regarding the brake emission, the exhaust emissions, we are focusing on Euro 6C cars, pre-R cars, so retrofitting gasoline engines. The filtration works. We have done that for vehicles on the road. We have also tested the particle emissions of up to 900 vehicles. It's running great. We have a solution, we know how it works, and it's working fine. For the brake emissions, we have done, as I will tell you a little bit later, a different approach, not using the brake cycle, but really going, as it's for cities, what's happening, how's the braking happening in a city. So we have data now to understand how the buses are braking in the cities that are our partners. We have a brake dust particle filter developed, tested. It's now on a vehicle going for winter testing. We are working on getting the emissions data and doing the testing. They have been delayed due to issues with the test rig setup, and we are on a good way to get the data. For the metro stations, we have used our filters. We have worked with Metro Lisbon to get them installed. I will explain that a little bit on some slides later on. We had some issues with the last campaign. Some sensors failed. There was this Sahara dust. So we are doing to repeat that measurements, and we will have then good data to feed for the life cycle environment assessment. So I spoke about some results. Let's give you some pictures. Regarding the exhaust, there's a great video on LinkedIn and on our website. In Lichtensteig done, you see all the process of retrofitting a car from getting the old exhaust system out and getting the new one in. If you look at the diagrams, you can see on the top the OE and then the reduced particles with the retrofit solution. It's working fine. There is no bad effect on fuel consumption. For NOx, we said if the original solution is not working, then we replace it with the original solution because that should work. So there is no NOx part on our side. We just focus on the particles. We achieve the efficiency, high efficiency. We have run the vehicles in Europe. Great work, no problem. Even the regeneration works under the conditions for the gasoline engines. Regarding the brake emissions, our focus is to look what's really happening in the city and how are the health effects later on in the city if we reduce particles over there. So we did measurements in Valladolid, in Ljubljana and Ancona with ICE engines as they're running, and Mauricio insisted on doing that with hybrid, and we wanted to get the CAN bus data. This took us a long time. We waited and asked again and asked again. Finally, we got access to it. Now we have the data. We can really see when the bus is braking, when it's recuperating. So we are analyzing the data at the moment. The tests are starting at Link for the emissions. Unfortunately, we have to postpone that site visit because we don't have the data yet. It will be in March, April, when we have the site visit to schedule. What else did we do? It's about healthier aerosols and in urban cities. So what is your exposure if you are standing at a bus station? It would be nice to measure that in a city, but with a scientific grade equipment, you can't place it in a public space. Luckily, we have the bus partner Avasa. They have a bus depot. So whenever a bus returns, we put a line over there on the street and said, stop here. And then we measured the bus braking, and we measured that inside the bus as well outside the bus, Unfortunately, some pictures had the bus driver on, so we had a GDPR topic to solve. It's solved now, we can work with the data. Also, our partner ZF showed the brake dust particle filter at the IAA truck, a big exhibition. You can see that truck with the glass transparent way. The filter was a great success, what I have been told. People are interested in, and it will now go on the trucks in Sweden, in Finland, for the winter testing. It passed all the tests, it passed on the road, so we're looking forward. And it came up the idea, why only buses? It can also be for waste collecting vehicles. So there could be a broader application for vehicles that are in an urban area because their braking is different than if they would be on the long haul. For the metro stations, we presented last time that we have identified tracers to let us know what emissions, what the exposure is related to the braking. This has been done, and now the installation. We had some issues getting them transported in the metro, getting them down to the station. It worked well. They have been installed, and if you look to the pictures, you can see art behind. That was one of the biggest problems, that they are covering art. So we need to be careful where to put the replacement. It can't be at every place in a metro station, but it worked very well there. One of the concerns was, what about vandalism? Will they be destroyed? Will they be spraying on? Luckily, this was a station where there's a football stadium close by. So there was a game with British football fans, no problem. There was also a concert of Taylor Swift, no problem. So we had all the extremes, it working great. What did not work were the measurements. Some sensors failed. There was the Sahara dust in that time when we did the measurements. So a lot of confusing things. We also had to learn that the HVAC system is turned off in the evening. So getting results, we can't make much out of that. So we had a lot of lessons learned. And we now preparing the second measurement campaign. And this will be at a different station. You can see the pictures. This is CFD simulation with an arbitrary exposure rate. The red is bad, the green is good. So with filtration, we can see an effect. And if you look at the decay, the effect will also be within a few minutes. So that's important because trains are passing and trains are putting new emissions in. And this will work quite well. We have placed the sensors, we have decided where to put the filters. So measurements will start. Quotation is currently going on for the installation, and measurements will start in a month. What else did we do? Preparing the market. We need to convince people that this is a great solution for an immediate effect on urban air quality. We are presenting at conferences. We organized a workshop on metro air quality. That was a great workshop. It's a big topic, but nobody wants to talk about it. If you talk to cities, they say, oh, yeah, perhaps, but we are commuting. We are the backbone of the city. Don't talk about air quality. But we have to, and there are cities that do that, and they want to make their customers happy, and there are now solutions that we can use. So we have been at Polis, and we have been at other places as well. So what will be the long-term effects? What will be the impact that we can generate with solid data with a good environmental life cycle assessment? The retrofit solution, it works. You don't need to get a new car. You can get the retrofit solution. Citizens will be happy. The city has a better air quality, so that should sell and that should work. For the brake dust particle filter, we are almost close with the type approval, so that piece can go in the market. We have demonstrated that the solution is working, no problems. It will survive the filter test, the winter testing. For the metro station, we are still missing some final proof of the exposure. Data is coming. For the life cycle assessment, this we need to do because we need solid data. We can't just do that with dummy values. So that will be the big task to continue on that. And why is that so important for me? There's the ESG, there's environmental social governance. There is how to prioritize budget, what products to do. There's green financing. All this is related if you can demonstrate an effect. You can go for an incentive, you can go for regulation, but this might not work for these retrofit solutions. But if you can prove that the budget you spend has an ESG effect and environmental effect, then you have a chance to prioritize and get cities, get mission cities, get cities to implement that for waste collecting trucks, for buses, for all the the city vehicles. So we have a framework. We are now waiting for the data to do that analysis. And we have also a great city like Lisbon who really cares about that. And if you know other cities, talk to us. We want to invite them for the final event and to make an impact with that one. So I would like to thank you. Follow us on LinkedIn. And I would like to thank the team of Aerosols. It's a great team, good work together, and we are happy to have got this project and to work on such great solutions. Thank you very much.
So thank you, Martin. Like Martin said, the final results will be available probably in June. So please follow them also to check when is the final event and to see the final results of this project. And we are happy to see that the filters are Swifties safe, so that's good. Now I would like to invite Professor Zizis Samaras. He was the director of the Lab of Applied Thermodynamics at the Aristotle University in Thessaloniki, and he will present the project VERA, which is from the same topic as AeroSolfd.
Thank you very much, Salima. Right, our name is much shorter, as you can see, and easier to pronounce compared to our sister project, AeroSolfd, and I don't think I need to explain much. It's about emission retrofitting activities. Of course, we are exactly in the same call, so we are very complementary, and we have many similarities with the previous project. However, we have some important differences. Maybe before I start, I wanted to say that I'm impressed by the fact that there is so much people here following this particular session, because it's about the old topic of internal combustion engine. And I will say why I say that, because of course our project incorporates a large number of institutions from across Europe, complying with all the needs of a proper European project. It's around 5 million financing. It started 6, if not more, months later than AeroSolfd, and it is expected to finish by November. However, we are already discussing with the Commission to have an additional extension of 6 months for a number of reasons. Most importantly, because of all these difficulties of the automotive industry, we had some internal rearrangements that had to be dealt with. So I don't expect that the project will be finished before early 2026. Now, we have been asked to look at retrofitting, and in my experience, retrofitting was never successful in Europe. There have been a big number of projects in the past, many of them financed by Germany, for example, for installing diesel particulate filters in diesel buses. This is an example only, there are other attempts, and unfortunately, they were never expanded. They stopped at the pilot phase, and this is a very interesting question, actually. Why? Therefore, the main question mark behind all those projects is what type of engines and vehicles are we targeting? And if we find the right, let's say, target, then how efficient the approach is in terms of impact assessment. I think Martin mentioned that a couple of times. We are a bit more focusing on cost effectiveness, including also impact as a whole, as I will explain. But we wanted to, as a matter of fact, to focus on the main targets of the call, which was asking for 90% less particles. It was asking for almost 50% reduction in NOx emissions. This is not mentioned here. And also, we should take into account ammonia side effects. That's what is meant in our understanding. And also, it has to be, I'm talking about exhaust emissions, of course, has to be costly, not costly. It should be less than 10% of the vehicle market value. This provides a large number of constraints, because most of the vehicles already now, they are equipped with a DPF or a GPF. There are only few areas where few vehicles, existing vehicles, which do not have a GPF. And since the call was referring to them, so we decided to go for natural gas vehicles, for PFI, because all DIs or direct injection gasoline vehicles are equipped after a certain point with GPF. So we had to look at PFIs, and then maybe some DIs which are not equipped with GPF. So it was not a straightforward, a straightforward exercise. Yeah, I have to put this one. Straightforward exercise to select the vehicles. It was easier to look at brakes, because brakes, they have not been really looked after until now. Therefore, it was relatively more straightforward to decide what kind of retrofitting we could do. And as I said in the beginning, our main objective is really to assess the overall impacts in terms of cost effectiveness. So what did we do? If we start with the exhaust retrofitting, first, we looked at the market if there is any available market system, and we didn't find but a prototype. This is a HYOTES HJS, which is nothing particular, if I may say that. It's just a GPF, canned, bare GPF, without any catalyst on it. But we took it, we installed it in a difficult, let's say, environment, which is a PHev Golf. This was a Euro 6B, and we tested it over a relatively large number of mileage. And we saw, of course, as we were expecting, a very high efficiency of more than 90%. And even more interesting, this efficiency was improving as ash was accumulating in the filter, which was something expected, without effect on pollutant emissions and without effects on CO2 emissions, which means fuel efficiency. So we said, okay, as our sister project does, I think we just validated that this is a possible approach. Then we said, okay, what is the innovation we can bring in, and how this innovation can be reflected into the project? That's why we turned into a low-cost three-way catalyst. And this low-cost is a copper-based three-way catalyst. As a matter of fact, copper is replaces partially platinum, but of course it continues to operate together with rhodium and in a more PGM environment. What they claim, our colleagues here from Athens, they claim that this can replace something like 80% of the overall PGM loading of a catalyst. And this is what we have. We have on a substrate of zirconia and ceria, of course, which is the standard substrate, we have this type of catalyst. And we want to test it in two applications. One is a PFI vehicle, which was selected, and the other one is a DI vehicle, gasoline DI, together with a natural gas operation. Actually, it's a natural gas operation. It's a Skoda Octavia. With it's called monofuel because it has natural gas and gasoline, but gasoline is 9 liters, so it's basically used only for starting the vehicle. So this is what we intended to do here, and not only this, we also looked at model-based design and optimization of the system because we wanted something that would fit to the particular application. Another thing we did, which is not the best that one could do, but it is the best one could do in retrofitting, is we only replaced the muffler, a part of the muffler. We didn't want to intervene with the ECU of the system, because if you enter into the calibrate, the overall calibration of the system, then this increases cost and makes things much more complicated, as we saw in PHENICE. So we mostly focused on the substrate and the catalyst themselves. Yeah, our first results, of course, indicate that we have a very good particle number efficiency of more than 94% over WLTP and many other cycles. So this was not our concern. I have to say, I'm not going to show any gaseous emissions effects. We don't have the expected 50 or 60%. What we do have is a zero at cold start conditions, because the catalyst is placed in an underflow position which is far away, therefore it cannot really heat up easily. But when the whole thing operates correctly, which means you have a heated up catalyst, then we have an additional reduction of the range of 10 to 15% additional to the initial reduction which is produced by original three-way catalyst. Now, the brake retrofits is an easier thing, easier from a concept point of view. Don't misunderstand him. It's much more complicated in terms of application. So here, what we do is we are using three approaches. One is an engineered cast iron disc with a tailored pad. Then the second solution is a coated disc with a tailored pad, and then a filtration system. All of them to be applied in different applications of vehicles. And we are testing them both in a brake dyno, in a brake standardized dyno, but also under real-world conditions using this equipped Audi, sorry, it's a VW, but it is operated by Audi vehicle, which is fully equipped for on-road testing of innovative brake solutions. And then we also do this, a similar thing we do in a metro. So in the metro of Madrid, but we're not following the approach of AeroSolfd. Actually, we're installing, or we want to see what the effect of a filter will be on the brake emissions on the train. So follow the same approach as for cars. And the first results on the brake dyno test indicate that the cast iron disc and the pad, which is the easiest solution, already indicate that we can have very high efficiencies. And these efficiencies are even better when the vehicles are smaller. And this is done on the basis of the brake tests, on the brake dyno tests, and they are confirmed also by the on-road testing. It is of interest because one can imagine, this is a different case, one can imagine that since every car has to replace its definitely the pads, but also the brakes, one can imagine that all the replacements after a certain point of the existing conventional cars can be done with improved, in terms of emissions, particle systems, improved brake systems for particle emissions. Of course, there are a number of data that we have collected looking at the baseline emissions, and what I want you to come up to take away from this is, of course, there is a very close relationship, linear almost, between friction on the brakes and particle emissions. However, the emissions of the brakes, we shouldn't forget in terms of particles, are extremely low. They're at least 100 of magnitude lower than what the exhaust emission level of a DPF equipped vehicle or GPF equipped vehicle is. So we are talking about a different chemical, physical characterization of those particles. And of course, the drivers can play a very important role into the overall emissions. This is a thing that is also done in AeroSolfd. We are going a bit different direction. We want to have an overall impact assessment to feed in our cost effectiveness calculations after cost and impact calculations. So in addition, we're running a relatively large physical-chemical characterization. We are also looking at air quality and exposure scenarios in confined places. This is metro stations and bus depots. We are running in parallel toxicological analysis of these particles. And we are trying, and there we would like to really have a closer collaboration with many others, including our sister project, on the incentive and regulatory schemes that can support this activity, because we would like to feed in our cost-benefit analysis. So for this, we have done measurements at the Madrid metro, similar question marks as Martin said before. However, you can see we have put our installation within a confined area, so it was not really affected by the people. So you can see all this installation by TNO was installed in metro in Madrid, but also in Amsterdam. These are some first results coming from Madrid, indicating that in the metro station, at least 2 metro stations we measured, 60 to 80% of the emissions measured in the metro station inside, they come from wheel and track friction. They do not come from the brakes. The brakes can contribute something like 20 to less than 20% overall in these areas. And something similar we are getting from Amsterdam, where when we make the comparison between the measurements in the bus depot and the city, we don't see big differences. And also the important thing here, if you look at the very small letters, sorry for this, of the percentages, you can see that something like 4%, 5% in Amsterdam are expected to come from brake emissions. 4% of the particle emissions. And this is the final picture I would like to leave you with that says that overall we are going to run, and we started already running an overall impact assessment. Oh, sorry, how would I go back here? Yeah, an overall impact assessment where we would like really to extrapolate in terms of cost effectiveness, take into account the benefits from reduced effects at European scale, but looking at particular scenarios that should take into account the introduction to these polluting, if you wish, vehicles or vehicle categories, the introduction of retrofit systems. I would like to kindly invite you to look at our website, which is one of the most beautiful websites I've seen. This is the only kind of, let's say, publicity I would like to do with this. We don't have too many news, but we are going to be much more active now because we started collecting data, which also they will be published in peer-reviewed publications, which is always the target of a university. Thank you very much.
Right, I'm Adrian Velaers from CONCAWE, and I'd just like to thank our 3 presenters, Tony, Martin, and Zizis, for some excellent presentations. It's very nice to have a session where we can talk about real engines again, and also to hear your innovative and practical solutions. And I would say also robust solutions, because if it can survive the British football fans, I think you can deserve that title. So we now have a generous amount of time to have some discussion and some questions. So I would invite the floor to pose these questions. Xavier over there will give you a microphone, so just please state your name and affiliation and address your question, and we'll have some discussion. Thank you.
Hi, thank you. Victor Lejona from CENEX. I have a question about the retrofit solutions for emissions, both brake and also tailpipe, and their relation to the low emission zones that a lot of cities are imposing. So what's your view on the relationship between them? So a lot of citizens are being kind of quote unquote forced to buy new cleaner vehicles, Euro 6, Euro 7, or even electric, to cope with that and to get the sticker on the windscreen so they can go into the cities without paying the fine. Why don't retrofit solutions kind of scale up and kind of respond to that challenge, and how can we kind of publicize a bit more the retrofit solutions and let the public know that they are available, and maybe they don't need to buy a whole new vehicle. Maybe they can, in their next MOT, like in the next technical inspection of their vehicle, in two months' time, they can buy that, or they can get some incentive from the local government or something to get the retrofit in their old vehicle, but still drive into the cities.
That's a good point. Not replacing the car, but having an immediate impact on the air quality. And for the tailpipe, it's working. And that's what the solution we are developing. And it's running. And the challenge is to convince the municipality, the city, that this is a solution to accept. They are all going for e-mobility. They want to replace the car park. But they can make their citizens more happier if they give them a chance. And that's why we need the environmental social life cycle assessment, and that's what we think is an important part to see there are health benefits. If you do that right now, it's cost affordable, it has an effect, people like it. You don't need regulations, it fits well to the low emissions. You can even get the public to go for a low emission zone and don't have all these fight against it because you have an easy solution. So that's what we are trying to convince, and that will be part of the final event. If you have cities who are somehow going for the step, let us know and we will invite them for the final event to show the results, and that's a great solution with an immediate impact. Later they will change to e-mobility, that will come. But for the cars now, it's a perfect solution.
I will be less optimistic. I'm sorry for this, but as I said in the beginning, these are retrofit systems for particles. So first of all, we have to make a calculation of how many vehicles are in our cities which are not equipped with particle filters. The second question is, how many of these vehicles are really used in the center of the cities where the low emissions zones are there. Yesterday, there was a presentation from another project under air quality. I don't know if you were present, which is called NPETS, that was trying to, between other things, to make some scenarios about what the effects of different measures can be in Stockholm, very similar. And one of the scenarios was focusing on what is the effect or possible effect of a low emission zone. By the way, is it a low emission zone or is it a low speed zone? I think it's a low speed zone, and first of all, this is how it started, and now it expands to look at what Euro class compliant each vehicle is. Nevertheless, this was an attempt to show an effect, a possible effect, if all the vehicles entering into a low emission zone would be zero emission vehicles. A very easy calculation. And it was not visible in the calculations, less than 1%, which is very difficult really to assess finally. But when the whole city was expanded, the calculation was expanded to the whole city, then it started being visible, much higher. And we're talking about particles. And more particular, these calculations were about nanoparticles. So below 100 nano. Now, it is not an easy exercise. And if I was a citizen, I would be wondering, why should I go and make this retrofitting? Why? Because there is an incentive or a regulation that says you cannot go there. All right, I will go around, for example. Or I will not use this car, I will walk. I don't know. Why should I go into this overall burden? It's not, I would have done it, I think. But if we go to the average citizen, why should he do this? I'm not sure we can be convincing in this. That's why this, even the social LCA, personally at least, I have questions. I very much, I'm in favor of these calculations, but maybe a much easier cost-effectiveness calculation would tell us, to a certain extent, I'm sure I will be happy to share those results maybe next year, because we are going to have in a more credible, at a more credible level, just to monetize the whole thing, because in the end, this is what it matters, it seems, from the results. So I said too many things, but I wanted just to give an order of magnitude estimate. So the first thing is take into account, look at the fleet in the city, how many vehicles are there, which is their age, because it's a matter of turnover as well. If you take another 5 years to take a decision, most of those vehicles will disappear. So why do that? Is it only for buses? But the buses are already equipped with diesel particulate filters. How many natural gas buses you have? I stop here. Thank you.
Yeah, I would like to add to that. The solution is for passenger cars. And I wouldn't look at who is really driving into the low emission zone, because if people get a chance to keep their vehicle and continue driving, they will do that retrofit if the city is pushing for that one. You might only enter it into the low emission zone. That's why you perhaps get it, because it's an affordable thing to do to keep your car. You can get happy. But you are driving around the city. So you will have that effect as in Stockholm, not only in the low emission zone, you will have that on a broader range. So the point is, from my side, what arguments does the city need? What arguments the persons need to do that retrofit, and coming together, it can be a win-win situation for them with an immediate effect. And I don't have the key and I don't have the right things right now, but I'm open for a discussion on that point.
Thank you very much for the nice presentations, the informational presentations. My name is Aristides Dafis. I work at the University of Magdeburg, the Otto von Guericke University, at the chair for energy conversion. I have a more technical question. You retrofitted the exhaust after treatment, and you lowered the emissions, the particulate emissions, and the nitrogen oxide emissions. Have you looked into the exhaust gas pressure, which could have raised? Because if you raise the exhaust gas pressure, you have influence on the scavenging efficiency, and the scavenging efficiency has an influence on the consumption. And we know that with the consumption, the rise of the consumption, also the CO2 emissions rise. So that's maybe could be a problem. Because I just saw the results for the particulates and didn't see any results for the CO2 emissions, so that's why I'm interested to hear that. Thank you.
I thought there was one very short sentence that there is no effect on CO2 emissions, but I can elaborate on this. The reason is very simple. What you say is that back pressure actually deteriorates fuel economy exactly because of the scavenging, of the effect on scavenging. The thing is that those GPFs, because we're talking about GPFs, they have a very low back pressure and non-measurable back. It is similar to the back pressure which is exercised by the muffler itself. And if you notice, we generally, this is what we all do, is replace a muffler, not, and because also the GPF plays a role of muffler because of its construction. You don't need the muffler anymore. It attenuates the noise. So you do two things. One is attenuation of the noise without side effects, and also without side effects on back pressure. And why the back pressure is kept low? Because you have a constant continuous regeneration of the filter. As soon as you have a little bit high temperature at the filter, and gasoline vehicles have something like easily 600 degrees, then you just burn whatever you have there. So that's the reason we didn't emphasize this, because this was expected. It is also shown by the old data we had.
Yeah, thank you for asking that question. It's a frequent question coming up. On one of my slides, there was the CO2 small print on that one that you can see. And if you need further information, I just turn around. Loretta is sitting behind you. She is the expert in our project.
Yeah, I think give the mic to Loretta. Thank you.
Okay. So good morning, everyone. So thank you, Martin and Zisis, for this very nice overview of the two projects. So I represent BERT, so we are involved in work package 1 for the AeroSolfd project, so the tailpipe emissions retrofit, and we have amazing actually results with over 50 vehicles that have been retrofitted already. We have durability studies. Unfortunately, it's just like a very short presentation, but we have papers already available. And definitely we did also an investigation of secondary emissions. That is also very important. We checked not only the GDI vehicles, but also the PFI. So we also can provide a lot of information on particle emissions from PFI vehicles that are not actually with filters. So, and the Commission is also doing, in particular GRC, also investigation on the PFI. So I think that, you know, the retrofit can for sure be a very important short, you know, term solution for cleaner mobility. So, and I would also ask, I would like to ask also Salima, what is your idea? How can we push forward this, you know, all the results, the nice results that we have got already with these two projects, and we will get more. Thank you.
You can go ahead. Thank you.
Okay. Yes. Well, one thing, some are questions to the audience, but I will also, let's say, comment on the comments that were made. First of all, number of vehicles. All PFIs don't have it. They are not few. So, and what you've demonstrated is that these are cleaner, a retrofit is cleaner than any new vehicle on the road. I mean, and this for the foreseeable future, because Euro 7 has no requirement whatsoever to improve particulates from engine. So, as a selling argument, I would say that you could stress to cities that rather than replacing the fleet, if it's not with electric vehicles, then it's a very cost-effective. And you said 1 order of magnitude the brakes less than engines. Filtered. With unfiltered is 4 order of magnitudes that you're reducing in terms of particle numbers. And therefore, I think that's another argument. I mean, one other project we had tested the PHEVs that had higher emissions for particles than the limit. So even on a PHEV, you can retrofit with some important benefits. And coming to PHEVs, I'm missing any data in the presentation on emissions because the requirements were quite important there. And, sorry?
Gaseous emissions.
Yeah, no, yeah, in the PHEV project in general, including particulate, because as I say, this continues. And yesterday, I think another speaker mentioned very clearly this, that they are seeing very high emissions from PHEVs due to continuous start-stop. Also there, I would like to know something. And also you mentioned the WHR, but I don't remember seeing any data on the results. Thank you.
Thanks. Maybe, Tony, I'll give you the opportunity to answer that. And I also had a similar question, which I could maybe add to that. I noticed you and your system had the catalyst preheating system. Of course, thermal management in a PHEV is difficult of the exhaust system, and that has the big impact of emissions. And I think linking to exactly your question, when you start-stop and you lose that temperature, you have the problem. But I was interested in your heating system and whether that was efficient or successful in your test work. So maybe some comments from you, Tony. Thanks.
Thank you for the question. So I'll start regarding the number in terms of emissions. Indeed, the objective was to make an assessment of the prototype vehicle on RDE cycles that we are seeing here. And yes, they are ongoing activity. It's the last activity. So of course, we will publish the results in terms of number. And I agree with you on the difficulty in terms of managing. And this is something that I mentioned, but very briefly. For example, in terms of calibration, we take also into account the exhaust after treatment temperature. That means we have some condition. For example, if the temperature draw below some limits that make us outside the, let's say, window of good functioning. So it doesn't allow, for example, the engine to shut off. So there is a lot of calibrations that were performed. That's why I mentioned it's emission-based calibration. So this is something. But again, they are a very challenging, let's say, target. And of course, we will see the results, what will happen. So this is on the first side. Second question was waste heat recovery system. Yes, we didn't mention here the result, but it was kind of very interesting work because we first we tried to simulate on the vehicle what can then be the gain in terms of efficiency, and we have some order of magnitude around 1% in fuel consumption with the second, let's say, waste heat recovery system. But once we started to, let's say, assemble everything and try to find a place for everything, there are clear trade-off between the different components. And since we have a lot of exhaust after treatment system components, that means the priority was to respect, let's say, to try to respect our emission target. What that means? That means that the exhaust after treatment recovery system was placed in very far. So that means this system see a very low temperature. So finally, when we replace exactly when we can, the gain was less than 0.1%. So that's why I didn't mention here, but the problematic is we have to make a trade-off. Once we install all this exhaust after treatment system, it's better to give the temperature and give us the chance to respect the emission limits rather than to try to recover. So clearly the conclusion was, yes, on the table it's very interesting, we can recover, but in reality it's very hard. So that's why I didn't mention, but this is the result, the main result. Is there any additional question or no? Okay.
If I can add.
Please. Thank you.
Because I was present in last year's presentation. Last year's presentation, and this table changed from last year or the year before, I don't remember now. There were your targets, and then there were Euro 7, and they were completely different limits, of course. They were the limits proposed by the Commission. And this was making the targets look very interesting and very timely. But now everything was without any change, actually. So it was much easier, their life. Because I think what you did was to propose much better performance than Euro 7, than the expected Euro 7 at the time of the call, isn't it?
Yeah, exactly. Thank you for this remind. Indeed, by the time that I was presenting 2 years ago, the discussion were going on, and there were some hypotheses of CONCAWE that were more stringent than this one, Euro 6. And one of the objectives of the project was to, let's say, okay, we have the initial target, which is grant agreement, and we should stick to this target, but also to take into account what is going on in terms of regulation, European regulation, because this also is important for the project. And yes, the number changed because first the hypothesis was CONCAWE, so we have taken this CONCAWE hypothesis, but now we have Euro 7, so that's why we changed with Euro 7, but the first column didn't move because it's the PHOENICE grant agreement target.
Thank you. Xavier, I think we have a question in the corner, but before that, Salima will respond to Loretta's question.
Yeah, so this is a very difficult question. So how to apply this retrofit system and how to incentivize this to the cities. So I think the last part of the two projects that are ongoing will be very important because we will see figures of the impact that it can have. And then, of course, the impact should be also more interesting in cities. So it may be also the prerogatives of the cities to apply this kind of regulation. and we will see what is the best solution at the end. Is it to add regulations? Is it to put into evidence the social impact from the cities themselves? So the last part with the recommendation is it's much weighted from those two projects.
So, thank you. My name is Mihai Kirka. So I'm representing Transdev Group. We are the biggest worldwide public transport operator as a private company. So we have roughly a few tens of thousands of buses. What I wanted to highlight it also to share with you is that in the last 2 years, I would say, retrofit is not anymore a taboo topic for companies as Transdev. And I think we are all together in a very positive period. We have up to 2029 to really make something in changement of the fleet. It's a fact. Authorities do not have money to change buses. So what all authorities are looking today is how to extend the life of buses. So I would say, maybe you know together or all together, the European industrial capacity to produce buses in Europe, it's only 1/3 of what we need to buy every year. When I want to buy a bus, I wait up to 2 years. So what I always do is try to extend the life of the bus. So the only problem that we have today is that retrofit is an R&D project. Each time that we want to retrofit something, it's a project, is not a replacement of something that we are used to. Public transport sector is not an R&D sector. We don't know at a very large scale, we don't know to use a lot of projects. I can do 2, 3, 10 projects around the world, but today if I want to change massively retrofitting some things, it's not possible. At Transdev, you are the biggest worldwide, and we only retrofitted 30 buses. So it's completely nothing from the field that. So my main question is how to change from the R&D discussion to the large scale. I'll just give an example. It's the same situation that we have between electrical buses and hydrogen buses. Biggest operator, we only have 50 hydrogen buses in our fleet. Why? Because hydrogen buses never went at a mature level product. And the electrical buses are like a product. So the question is how to scale up, how to transform this R&D in product that were on the market and we would buy it and someone change. And the very last thing that I want to share with you, even if we're the biggest operator, we don't own the buses. So the buses are owned by authorities. In general, those authorities, they have roughly 40 buses in a fleet. So when an authority has 40 buses in a fleet, I don't count very large cities. They do not know how to deal with this R&D. So they want to go on the market, buy something, or have some chain there that help them to change something. So that was more a statement than a question. Thank you.
Thank you. We are running out of time. It is lunchtime, but I think we can maybe steal a minute or two if there is a response that you guys would like to make quickly.
Retrofitting of buses was, I think, very successful in Germany with some smaller bus operating companies. The other point is, in AeroSolfd, we are developing and we get type approval for a solution that can be retrofit. So if you renew the brake system, the caliper, and if you renew and you have an add-on of the filter, it's a solution that does not need further development. It's something that can be fitted to vehicles. And for example, for waste collecting trucks, if you do a replacement of the caliper, it will work. So we need to look at the right cities that are willing as an operator to say we want that. And then it will be a solution implemented. Of course, it's for not for every bus that's running long haul and so on, but there are smaller companies that are willing to implement that. So we need to find pioneers to do that, and then it will go helping you to extend the life of a vehicle.
Are you referring to exhaust filtration retrofitting or to brakes? Sorry?
We're retrofitting everything that is possible. We're retrofitting diesel buses to electrical buses, we're retrofitting brakes, we're retrofitting. So all topics for retrofitting are quality today.
Yeah. But my understanding, you were mostly referring to exhaust emissions, not so much about brakes, did you?
No, brakes.
Brakes as well. For low emissions or for better performance and durability? Sorry for asking, but I want to...
For a better image.
For a better image? Yes. Yeah, that's interesting.
They just want to use the status quo. So when you want to differentiate it, you propose something more that the regulation asks you. So today, very clear, you don't have money for that, you don't have incentive regulation for that, you only have an image game to play.
Right. Then I think a brake retrofitting is probably, I would agree, is probably the best way, really, of differentiating yourself, doing something which is necessary anyhow, and which will also improve performance, emissions, and your image. Now, exhaust retrofitting for diesel buses, not only natural gas. How many natural gas buses are in your fleet?
I think roughly 10,000.
Out of?
Out of 60,000.
Then this might also be a possibility. Then a natural gas GPF application could also be a possibility at an affordable cost. It's not a research project because it's not going to change anything in the operation of the bus. As I explained, or I tried to explain, this can only replace, should only be there in the place of the muffler. And that's it. And then you forget about it. And then, of course, with all the measurements, as Mauricio was saying, under all conditions, particle number emissions will be extremely low under all driving conditions. This is not a research project. It is more, a direct application.
Okay. Thank you very much for this very lively discussion. Luckily now it is lunch, so we can continue this over lunch. I remind you all to please have a look at the exhibitions that are on display in the lunch area and enjoy the time. I think we can put the slide up for the next sessions, so we've got quite a bit of time until 2:15, and those are the next sessions following that. So please enjoy your lunch and continue the discussions. Thank you very much.